Students, now we shall continue with the problems based on continuity. As I have already told you, the mathematical definition of continuity is for any function, if you consider y is equals to f of x, which is a real valued function in the closed interval AB, and a function is said to be continuous at the point x is equals to c, which belongs to the open interval AB, if limit of f of x as extends to c is equal to the value of the function at x is equals to c. Now based on this, we are going to consider the problems. Now let me consider the first function as discuss the continuity. The problems will be in this manner: continuity of the function, discuss the continuity of the function f of x is equals to 2x plus 3 at x is equals to 1. So they have given the point as x is equals to 1. Now according to the definition, first what I have to check is the limit and also the value of the function at x is equals to c. So here c value is 1 and here they have not given the interval, so the interval will be for all the real numbers, for all x belonging to R it is. So first what I will do is consider this function f of x is equals to 2x plus 3. Now at x is equals to 1, what is the value of this function? So it is 2 into 1 plus 3, which is 2 plus 3, that is equals to 5. So here f of 1 will be 5. Now I will be checking the limit of this function as x tends to 1. Also limit of f of x as x tends to 1 is equals to limit of 2x plus 3 as x tends to 1. So if I directly substitute x is equals to 1, it is not going to take any intermediate form. So directly substitute. So it is 2 into 1 plus 3, that is 2 plus 3, that is equals to 5. So since limit of f of x as x tends to 1 is equal to the value of the function at x is equals to 1, what do we conclude? The function is continuous. We conclude that the function happens to be a continuous function. As another example, if we take, I will take the another example. We are discussing about the continuity of the functions, right? We are discussing about the continuity of the functions. Now as another example, I will be taking discuss the continuity of the function f of x is equals to 5x minus 3, right, at x equal to 0, at x equal to 0. Now the value of the function at x is equals to 0 will be minus 3. Similarly here, limit of f of x as x tends to 0 will be equal to limit of 5x minus 3 as x tends to 0. So it is 5 into 0 minus 3, that is equals to minus 3. So since limit of f of x as x tends to 0 is equal to f of 0, the function is continuous. We conclude that the function happens to be a continuous function. Now these were the straightforward examples. Now let us take another example, right? So another example is f of x is given to be 2x square minus 1 at what point? At x is equals to 3. Now f of 3 is equals to f of 3 is equals to 2 into 3 square minus 1, 18 minus 1, that is 17. Also here you can directly substitute f of x as limit tends to 3 is equals to limit of 2x square minus 1 as x tends to 3, that is equals to 2 into 3 square minus 1, the same thing that you are getting 9 into 2 is 18, right, minus 1, that is equals to 17. So here both the answers are the one and the same. So here also we say that the function is continuous at x is equals to 3. Now if the functions for the values less than c and greater than c are defined in different manners, then how to check the continuity of the function? So if the function is f of x is equals to 2x plus 3 for the values x less than or equal to 2, and if it is 2x minus 3 for the values x greater than 2 at x is equals to 2, if you want to discuss the continuity. Now here remember, if you want to understand this, just to draw a real line, and see at what point we are going to check the continuity. We are going to check the continuity at x is equals to 2. Now how is the function defined? For the values, first check for the values less than 2. So that function you are going to keep it on the left hand side. So it is 2x plus 3 at x is equals to 2 because it is less than or equal to 2. So at x is equals to 2, the function is defined by f of x is equals to 2x plus 3. And for the values greater than 2, the function is defined by f of x is equals to 2x minus 3. In this way you have done. So this function graphically I have shown here. So at the point x is equals to 2, you are going to consider. Now what is the definition of the continuity? F of x, limit of f of x as x tends to c should be equal to f of c. Should be equal to f of c. So at x is equals to 2, f of x is defined by what? 2x plus 3. So it is 2x plus 3. So it is f of 2 is equals to 2 into 2 plus 3. F of 2 is equals to 4 plus 3. So here f of 2 is equals to 7. So at x is equals to 2, f of 2 is 7. Now here if I want to find the limit of f of x as x tends to 2, I have to apply LHL and RHL, and both should be the same. Remember, both the limits should be the same. So first I will be trying LHL. So here LHL, last year you have studied limit of f of x as x tends to 2 minus. So it is limit of, how is the function defined for the values less than 2? It is defined by 2x plus 3 as x tends to 2 minus. So change the limit. So it becomes limit of 2 into 2 minus h, 2 minus h plus 3 as h tends to 0. So it is 2 into 2 plus 3, that is 4 plus 3, that is equals to 7. So here the value of LHL is 7. Similarly have to find RHL. So here RHL will be equal to limit of f of x as x tends to 2 plus, which is equals to limit of, now come to this graph. So for the values greater than 2, here the function is defined by 2x minus 3. So here it will be 2x minus 3 as x tends to 2 plus. So change the limit. So it is limit of 2 into 2 plus h minus 3 as h tends to 0. So it is 2 into 2 minus 3, that is equals to 4 minus 3, that is equals to 1. Now here the limit does not exist, since LHL, your conclusion should be, since LHL is not equal to RHL, the function is discontinuous. So according to the definition, if the function is not continuous, then it becomes to be discontinuous at x is equals to 2, because here the condition is not satisfied. Every answer should be the same. 7 means here also I should get 7, but here what I am getting 1. So I have written that the function is discontinuous at x is equals to 2. Further problems based on this type only we will be doing it in the next class. Thank you.